Hi everyone, and welcome to our second webinar on phenolic compound management. Today we are going to focus on red wine and color stabilization. My name is Églantine Chauffour. I'm the winemaking product manager at Bucher, Vaslin, North America, representing LAMOTHE-ABIET, and I will be your speaker today. So before we dive into the topic of the webinar, let me introduce you the two partners. We have Bucher Vaslin, designer, manufacturer, and seller of material for grape and wine processing since 1856, and LAMOTHE-ABIET, renowned winemaking product brand for their high quality and premium approach. They have been founded in 1878 in Bordeaux, so it's about 140 years of expertise in winemaking consulting, mainly in Europe. We are now making it available for you in North America. As Bucher Vaslin in North America is expanding their portfolio, we also distribute Coastal bottling line and Caso wine pump in addition to LAMOTHE-ABIET and Bucher equipment. For more information on Bucher Vaslin North America, please visit the website bvnorthamerica.com. You will have all the information you need. Okay, so now let's focus on phenolic compounds. Phenolic compounds has a strong they have a strong influence on red wine quality as they determine color and mouthfeel by impacting bitterness, astringency, structure, aggressivity, softness, but they are also responsible of wine longevity. Okay, they are mainly derived from grapes, so that's why we are talking about grape potential. And the type of phenolic compounds plus their concentration will vary depending the varieties, the vintage, the winemaking practices, but also the vineyard practices and the maturity of the grapes. So we have two categories. We have the non-flavonoid category, which are precursors of oxidation. They have the hydroxycinnamic acids. They are present in the flesh and very easy to extract. Then we have the flavonoids category, which are present in the skin, seeds, and stems. It is a category that we are mainly going to focus on because it is the most important group in red wines. Okay, in this group we have anthocyanin. Anthocyanin is actually, they are the pigment of the wine, so they are responsible of the wine color. They are present in the skin, it's in the vacuole, in the cells vacuole, and so they are water soluble, which means that they are pretty easy to extract at juice phase. They will be the first one being extracted when we do a maceration. Then the main concern with this anthocyanin is that as soon as they are free, in a free form, they are unstable, so they need to be stabilized, and this will happen via co-pigmentation and condensation. So first we want to extract these compounds, but then we need to stabilize them, otherwise we will lose all the color of the wine. Okay, second compound is going to be the flavonol. Flavonol is actually, so they are a class of flavonoids that we don't look so much at, but they are very important because they are actually the first copigment of the anthocyanin, so this helps with copigmentation and stabilization of the color, but also there is some studies that show that they are associated with higher value wines, so all the high value wines tend to have a higher concentration of flavonol. Then we have condensed tannins. So condensed tannins are coming from the grapes. They come from grape skin, seeds, and flesh. They consist in repeating flavin-3-ol units, which includes catechin, epicatechin, gallocatechin, and epicatechin gallate. So when they come from the skin, it's mainly about epigallocatechin derived subunit, but also there is some trace of gallocatechin and epigallocatechin. It is a higher degree of polymerization, so they are longer chain tannins. Then if we look at the seeds are usually much smaller. We are talking about 2 to 16 subunits, mainly composed of catechin and epicatechin. So seed tannins, shorter tannins, are actually very astringent and bitter. They are related to bitterness. Okay. Then the last category of tannins that we can find in wine is actually not found in grapes, they are the hydrolyzable tannins, which are coming from the wood. So they are actually units of gallic acids, and we find them, we call them gallic tannins and ellagic tannins. Okay, so usually they come from the oak that we are using with the barrels. Okay, so now, as I was telling you, we want to focus on color stabilization today. So let's talk a little bit more on how can we stabilize these anthocyanins that are the first one that we extract. So the first action that we can do is playing on co-pigmentation. As soon as these anthocyanins are extracted, we need to stabilize them or protect them. So co-pigmentation is actually consists in interaction with anthocyanin with weaker bonds. So it's not a completely stable color, but it is a semi-stable color, which is gonna last for a few years. So very common in young wine, but also it allows the anthocyanin to be protected and not react with everything else, such as protein or oxygen. Okay, so for this we can use, so the best one is to use co-pigments, such as flavonols. Okay, there is like thousands of co-pigment compounds that can exist, but flavonols are the best one, as we saw previously, because of their planar structure, and so they can stack the anthocyanin as a sandwich-like structure. Okay, but also we can use hydrolyzable tannins and non-flavonoids and amino acids, organic acids, polysaccharides can be used, as you can see here. Polysaccharide actually interact in a different way. So the first co-pigment with flavonols is going to be a van der Waals interactions, which is a weak interaction. Polysaccharides are actually going to bind with anthocyanins through hydrogen bonds, which protect the anthocyanin and avoid interaction with other compounds. Okay, we still speak about co-pigment. The co-pigmentation is going to depend on the concentration of the co-pigment versus the pigment ratio, but also pH and temperature. It does has hyperchromic and bathochromic effect, which means hyperchromic effect means we are increasing the intensity of the color. Bathochromic effect is that we are shifting the hue towards purple. So usually young wine appear to be much more vibrant and purple color and intense. That's usually due to co-pigmentation. Then through aging, the anthocyanin is actually not lost. The anthocyanin will leave its co-pigment to condense, which is the other reaction we're going to talk about. So to stabilize color, it's a slower process and it will take more time during aging, but we can have condensation. Direct condensation, anthocyanin tannin. So in this case, anthocyanin is acting as an electrophile and will react with the flavanotriol. This is usually happening when there is presence of oxygen, and it leads to a more purple color, as you can see in the screen. Then we can have tannin anthocyanin complex. So flavanotriol is electrophile and get attacked by the anthocyanin in this case. We don't need any oxygen, we don't need any light. This is the most common reaction that we can see during aging. It's a slow reaction and it's associated with more a brick red color. Ethanol, not ethanol, but condensation via ethanol bridge. So this is actually leading to the most stable color we can have. It is a very stable molecule that very often happen just after fermentation, alcoholic fermentation, because basically to have this reaction happening, we need free anthocyanin, we need catechins, and we need acetaldehyde. So it means we don't want any sulfur because it will bind with acetaldehyde. We don't want the bacteria to be active because they eat the acetaldehyde, so we need to be at the end, and yeast as well. So we need to be at the end of alcoholic fermentation before malolactic. Okay, to really optimize this reaction, obviously can still happen during aging. So the last type of condensation that can happen also happen during aging, and it is a condensation with ellagic tannins. So we need oak for this. And it's leading to a more purple color as well. So you can see more or less the color that is associated with each tannin anthocyanin complex. Okay, so here it was a little chemistry reminder. Now let's talk a little bit more about, more concretely. So let's talk about what can we do and how can we do it to maintain a good phenolic structure and have a nice stable color. Okay, I'm gonna talk only from the harvest to end of fermentation process, because then for aging we will have another webinar for it. Okay, so the first step we are gonna talk about is actually extraction. Okay, since phenolics are present in skin, seeds, and stem, they have a lot of molecule to diffuse through, and it's not always easy to extract. So we're going to talk about extraction, actually extractability of these compounds, because it varies strongly with the varieties, the thickness of the skin, vintage, and maturity. But also, what is important to talk about is that each compound don't extract at the same time and in the same way, because of their size, because of their interaction with other compounds, and also their solubility in water or alcohol situation. So we are going to see tools to increase this extractability if needed, but also tools to change the ratio of the different compounds to make sure we can stabilize them. So let's look at the extraction. So this is mainly to show you how the kinetic of extraction during fermentation. And where I want to focus your attention is mainly on the fact that the pigments, which are the free anthocyanins, are extracted much before the tannins. Then we extract the tannins of the skin, and then we get to the tannin of the seeds. So this is very dangerous because free anthocyanins are very unstable and will react with everything else around, such as protein, but also oxygen and some other compounds, and we will lose them. Okay, so the goal is to actually move this skin tannin curve a little bit more towards the pigment curve, so we do have enough tannins to stabilize our pigment. The second graph on the top of the screen is actually showing the same, except that when you look at the bound anthocyanin, you can see that this reaction really happens towards the end of the fermentation, because it takes time for the tannin to be extracted and then start to react with the free anthocyanin. Okay, so what are the different methods and tools available for winemakers to improve extraction in case you do have thick skin, in case you have a vintage that you really need to work on the extraction, in case you had to pick and it was not the optimum extractability of the compounds, you want to see how you can increase it. So the first step will be about crushing. Crushing can increase the juice-skin ratio, but also crushing will allow the better extraction in phenolics of the skin and the seeds. So the idea here is to try to increase the extraction of the skin compounds and all the positive compounds without extracting too much of the negative compounds. So we don't want to touch too much on the seeds. Crushing also promotes oxidation. So crushing is a good way if you need some juice, but pretty much that's it. Or if you already have ripe seeds. Cold soaking. Cold soaking, we have very different results depending the variety, but in general, it doesn't really allow anything for the color because you are extracting mainly your anthocyanin soluble in water, which you make them very free, and you make them react with other compounds and lose them. So you actually lose more color in cold soaks than you gain. Then cold soak is usually made for aromatics and having this complexity of aromas and microbial complexity. Okay, next step is a saigné. The saigné is actually a very interesting approach because you can increase the skin contact ratio. You actually concentrate everything, all the compounds. So it's increasing the anthocyanin, it's increasing the skin tannins, not really much about the seeds tannins. But also you must have good grapes, because if you do have some green character, you're going to extract all the green character as well. If you do have some mold, you will extract more mold. So you have to be careful with which grape you do it, because it is really a process of concentration. SO2 is acting as a solvent. SO2 is going to degrade the cell walls of the grapes, and facilitate all the extraction of phenolic compounds. So you will have more phenolics in a grape in high sulfur contents when you treat grapes with sulfur. Then you can use pectinase. Pectinase are here to lose down the cell walls and the pectin of the grape. So in this way, you can actually increase the release or increase the diffusion of the phenolic. So you increase the extraction of the phenolic compounds, but not only, and we're going to talk about it just after, but you are also increasing the yield of the free run, and you are increasing the polysaccharide content. That is very positive. You can do a thermovinification. You can play with fermentation temperature. This will allow you a very strong extraction. It's also a good tool to play with within an acceptable range for your yeast to be resistant and not suffer too much. So many studies has been done on this, and really, like, it seems that around 30 Celsius and 86 Fahrenheit is the sweet spot to get more extraction of phenolic compounds, better polymeric, more polymeric pigment without stressing the yeast too much. If you get higher in temperature, especially when the alcohol content gets higher as well, you are going to start to extract a lot of seed tannins and lose anthocyanins. So interesting to do high temperature fermentation at the beginning of the fermentation and maybe press early, but stop the contact with the seeds. Cap management. You will see there is many different ways to manage your cap, but there is also many different results depending on the variety and the maturity of the grapes. So you can play with délestage, you can play with pump overs, you can play with punch down. There is many different ways. We're going to talk about it. Last part is extended maceration, where I know some people believe that extended maceration is great for color stability, but all the studies are actually showing that we lose anthocyanin, we just extract more tannins and more seed tannins. So extended maceration, again, one more, it's like cold soaking. It is really more about extracting more seed tannin and working on the mouthfeel to get more polysaccharide as well, but not much about the color. So it is a useful practice to do if you have very ripe seeds and you want to have these tannins and this structure from the seeds. Okay, so if we do look at the enzyme, OENOZYM crush red is a LAMOTHE-ABIET enzyme. So as I was telling you, LAMOTHE-ABIET focus on premium products. So when we talk about premium product in enzyme, we are talking about high purification level. So OENOZYM crush red is a liquid pectinase that is highly purified and highly concentrated. We are purified of cinnamyl esterase activity, which means we are not going to produce precursors of vinyl phenols, which are the bread taint compounds. And then we are purified of anthocyanase, which means that we don't have the activity that could cut the sugar associated to the anthocyanin that will make the molecule even more unstable and react as soon as they find something and basically disappear. So it is a very important activity to make sure we are purified of if you focus on color stabilization. Highly concentrated means you want to use very small dosage, so we are talking about 10 to 30 ml per ton. Using this enzyme on grapes, so we use it usually after fruit processing, so after desteaming if you destem or just when you fill your tank. But basically we show a big increase of rhamnogalacturonan, which are the small polysaccharide that actually participate to color stabilization. If you remember, they can bind with hydrogen bond to the anthocyanins, but they can also bind with hydrogen bonds to tannins and participate to the mouthfeel of the wine and make a very soft and high body wine. We are going to increase the extraction of tannins by losing the cell walls. Same thing with the color. We are reducing the prag that you can see here. The prag are mainly the pectins that are, or polysaccharide that are rich in arabinose and galactose, which are responsible of not settling and not filtrable wine. So like this, you will increase filtrability. And by losing down the cell walls, you're actually increasing the juice extraction also, and you're increasing your yield of free run, so qualitative wine volume. So you improve color stability, you improve mouthfeel, you increase the qualitative volume of wine, and you improve filtration and settling. Then cap management techniques. So again, it has to be adapted by variety, maturity, and style of wine you want to make. It is very variable because everybody has his own approach and own way to do things with his own tools. So it becomes very complicated to find results that make sense and that are actually homogeneous through different studies. So many studies say one thing and the opposite. But if we want to generalize, we can say that délestage is going to be a strong extraction that can increase the free run yield. Délestage is going to be a practice that, so you are emptying completely basically the juice, letting the grapes having a self-pressing. So that's why you increase the free run yield, because you are acting like a very low pressure pressing. Then once the juice is completely drained, you are pumping it back on the grapes. It is a very strong extraction, so very interesting at the beginning of fermentation, but then you have to be careful towards the end when you start to have more alcohol, because you are going to extract much more seeds. Pump overs is probably the most commonly used way to extract and to manage the cap. It is a gentle extraction, but well, in reality, gentle, depending how much you make during a day and then the volume you pump and also the irrigator you choose, you can have a pretty strong extraction too. So it's gentle to strong, and it really depends on the tool you are using. So you want to adapt frequency and volume to the grape quality and the fermentation stage. So usually you go very slow at the beginning. When you start to ferment, that's when you do a lot of pump overs. And then as soon as the alcohol starts to reach 7 to 8%, you want to slow down, because you are going to start attacking the seeds. Punch down is a gentle extraction. Again, it depends how you make it, because if you are like pushing very strong and like crushing the grapes and the seeds, it will not. But in general, it is a gentle extraction, and we are much lower in the seed tannins, but just be careful with whole cluster. It's usually used on whole cluster wine, since there is no juice. That's pretty much the only way we can manage the cap. But then you can have a very strong extraction of the stems. So be careful with it. Okay, the other method that can exist are compressed gas or submerged cap, or even pulsar methods. Okay, the second approach we are going to have, if we are talking about protection of phenolics and also color stabilization, is going to be about protection. So we are going to talk about how we can limit the loss of phenolic compounds, so limit the loss by oxidation and limit the loss by reaction with protein. So basically what happens, as soon as phenolics are out and as soon as juice is out, there is some phenolics, which are the hydroxycinnamic acid, so the non-flavonoids that we saw on our first slides when we talk about the phenolic compounds present in grapes. They will be reacting with polyphenol oxidase and lacase, which are oxidative enzymes present in juice. And in presence of oxygen, this enzyme will oxidize the phenol into a quinone. This quinone is going to be first captured by the glutathione, so trapped by glutathione, which is our first and best natural antioxidant from the grapes. Then when the glutathione is used, we are going to talk about phenolic polymerization. That's where quinone will oxidize all our phenolic compounds. This reaction goes very fast, and you are going to lose your anthocyanin and your phenolics. I'm showing the apple here because it's exactly what happened in the apple. As soon as you cut it, you have the oxygen and polyphenol oxidase that is in contact with air and phenolic compounds, and then the phenolic polymerization happens, and then you start to have all this brown pigment. Last part is that quinone can react with aromas and also drop some aromas. So we will have to be careful with oxygen and with trying to basically inhibit the polyphenol oxidase and the lacase. Second type of reaction that can happen, as soon as we extract phenolic compounds, we also extract proteins. It happens that protein and tannin react strong together. That's why we use them as fining agents, such as gelatin or casein. So in this case, we don't really want to remove our phenolics, but that's what will happen. Our first phenolics out will react with protein, they will form an aggregate that will be too heavy and not soluble and will precipitate. So we will lose our phenolic compounds. So to limit this, we actually have some winemaking tools which are called sacrificial tannins. The one from LAMOTHE-ABIET is called protannin R. It is the most reactive tannins with protein that you can find on the market. We recommend to put 180 to 250 grams per ton at harvest as soon as possible, basically. It is a pure pro-anthocyaninic tannin that is strongly reactive with oxygen and with protein. So it will have this antioxidant effect, but mostly it's going to react strongly with protein. So you limit, E is the one that is going to react with protein and precipitate, not your own phenolic. But also, E is the one that is going to inhibit the PPO and the lacase to avoid this oxidation reaction to happen. And then protannin R will improve clarification as well by reacting with protein. So just want to show you some results. Here you have a result of, you have some numbers. It's a juice, grapes that were contaminated with botrytis. We look at the lacase activity, which is here represented in unit per mil. And we did a test that told us that with 20 grams per hectare of protannin R, we will be able to completely inhibit the lacase activity. So we tried 10 and 20. Okay, we tried half dosage as well. You can see that already half dose is helping a lot, stopping the activity of the lacase. From 4 we pass to 1 and then 0 with 20 grams per hectoliters of protannin R. And in the wine, that's the most interesting, when you have grapes that are contaminated with lacase, actually the wine still have a lot of lacase, and the lacase will still oxidize. The reaction will be much slower, but lacase will still be active. So as you can see in the control wine, we still have 3 units per mils, while if we put 10 grams per hectare, we still have 1 unit per mil, but with 20 grams per hectare, we are at 0. So we completely stop the reaction of the lacase. That's the color of the final wine that you can see. So it speaks by itself. You can see that we really saved the color and saved the anthocyanin and the tannins by using protannin R. Then if we look at the not contaminated grapes, so we did the addition of protannin R at harvest at 180 grams per ton, and we are looking at after malolactic the color and the in phenolic index. And as you can see, we saved a lot of color, mainly about the red color. The 520 absorbance is actually much more conserved. And then if you look at the green point here, which represents phenolic index, we are actually more than double. So we completely preserved. The addition of the protannin R is actually not really counted here because it's going to precipitate with all the protein, so we don't really see it in the final wine. What we see here is what we protected. Okay, so after protection, so since we extracted and we protect, now we want to stabilize our color. To stabilize our color, the main question is, since we talk about how to do this, there is a complex tannin anthocyanin, anthocyanin tannin, co-pigmentation, anthocyanin tannin via ethanol bridge, condensation with ellagic tannins as well. So it is pretty complicated. So we did some studies and tried basically to find the most reactive tannins with color that will not impact the mouthfeel. So we did this test of polymerization by ethanol, which consists in having a solution of tannin, then you add ethanol, and then the haze is going to appear. That's the reaction. So basically the haze intensity is going to give us information on the efficiency of the tannin, and the haze apparent speed is going to give us information on the reactivity of the tannin and how fast they can fix the color. So if you look at the result here, we are comparing two grape tannins, 2 catechins, which are more seed tannins, which are known to be usually reactive, and SOFTAN V, which is a formulation that we developed in purpose for color stabilization. You can see that SOFTAN V have the strongest haze, so strongest turbidity, highest turbidity, but also it is the fastest to have turbidity appearing. So SOFTAN V is going to be a very efficient tannin to stabilize color that is very reactive. And we did, this formulation is focused on color stabilization, so you will see later that there is no impact on the mouthfeel. It is catechins and plant polysaccharide that are bonded together, not mixed powder, but the molecules are actually bonded. So a little bit more results on the SOFTAN V. Here we added at 30 grams per hectoliters at the beginning of the fermentation. And as you can see in a Pinot Noir or in a Bordeaux wine, so Cabernet Merlot blend, we get the same type of result. We look at the total phenolic index, control SOFTAN V, control SOFTAN V, we have an increase of 9 and 7%. The amount of tannins, control SOFTAN V, control SOFTAN V. Here we have an increase of 18% in the Pinot, 9% in the Cab. Color intensity, we are both having an increase of between 13 and 16%. And then if we look at the stability of the color, so that's very important. And we look at the haze produced when we do our stability test. And the lowest the haze and the most stable is the wine. And as you can see, we have a much better stability of color when we use SOFTAN V. Another example here in Grenache, so I try to take different varieties to show you a little bit everything. Here we are looking at when we apply SOFTAN V at 1/3 fermentation or 1 day after fruit processing. On both cases, we look at the loss of color between alcoholic and 6 months after alcoholic fermentation and 6 months after malolactic fermentation. And you can see that the control lost 39%, while the two others lost between 23 and 20%. So very interesting tannins to stabilize color, but not only. If you look at the graph here, this is to show you the tasting. So it is the same wine than the Grenache actually. So it's like 6 months after Malo. We did a tasting and the green line is a SOFTAN V added 1 day after fruit processing. And you can see that we increase the structure, the length, the softness, the color, the balance, the aromatic intensity. Basically everything is very positive. Since I don't want you to take only my word, I try to put some opinion of other winemakers around that used it last year. And we have Christian Reguenon here, that is an extremely good winemaker that used as like more than 35 vintage of experience all around the world, but settled down in California. And he used many different tannins, but after using the SOFTAN V, he told me that it was an exceptional tannins and the best on the market, because basically you get a very stable color, you improve the color stabilization, and you don't impact the taste of the wine. It's completely integrated and you can't find the tannin. So I found this was a good comment I wanted to share with you. The other approach to stabilize color, and mainly if you do have varieties that are very strong in tannins, so if you don't want to add tannins and phenolic compounds, phenolic content is not really your worry here, but you still want to stabilize them, we are going to talk about manoprotein. Manoprotein can act as a protector and as a copigment. So here a table, some data coming from Escott from 2002, where we are looking at the gelatin index, which represents the astringency, PVPP index, which represents color stability and bound anthocyanins, and ethanol index, which represents sweetness. And you can see that we have the controls, and we have some manoprotein coming from yeast number 1, manoprotein coming from yeast number 2. You can see that on both cases, the manoprotein are reducing astringency, are increasing color stability, and are increasing sweetness perception, but they don't react the same way. So knowing this, LAMOTHE-ABIET did a lot of work on manoprotein to find the manoprotein that will best stabilize color, but also have an impact on reducing the astringency perception. And that's how we came out with NATUR Soft. So NATUR Soft, here you can see some result of trial where you see we are listing here the different anthocyanins. And you can see that basically control compared to NATUR Soft, we always have more anthocyanin preserved with the NATUR Soft than the control by itself, because we did complex some of this anthocyanin and protect them. And then if we look at the color stabilization, color stability, here we look at the delta NTU. The wine is considered stable under 10. And as you can see, the control is completely unstable, while when we add NATUR Soft during fermentation, we made the wine completely stable in terms of color. Then if we look at the mouthfeel, we completely change the curve. As you can see, control in blue, Nature Soft in red or pink. The curve goes completely towards roundness. We are reducing astringency, we are reducing dryness and sweetness. So monoprotein tend to have this impact. In addition to coating tannins and coating anthocyanin and protecting them, they also basically bind with the tannins in a way that our salivary proteins will not be able to bind with these tannins, so we don't perceive this dryness and astringency. We don't remove the tannins are still there, they are just stabilized and not as reactive as they could be with our protein salivary protein. Okay, so if I want to make a little conclusion of this webinar, basically, if we look at our potential, which is considered as 100% potential, after this steaming and when we are filling the tank, we have two risks. One is the early precipitation of tannins with the mast protein, and one is the early oxidation by lacase and PPO. So we want to protect our phenolic potential, and for this we will use protannin R, 150, 180 to 200 grams per ton. It is instantly soluble tannin, so you don't have to completely, like, it doesn't take time to rehydrate. In reality, you could almost use it directly on grapes. Then the second step is going to be about the extraction. So we are going to play with, you can play with temperature of fermentation, cap management, crushing or not, the steaming that you choose actually before, and also enzymes. So OENOZYM crush red is an enzyme that will help you to extract the compounds you want and still have other positive side effects, such as increasing the free run yield and also reducing the amount of pectin, so improving settling and filtration, and also extracting more polysaccharides. Okay, during fermentation, we are talking about stabilizing color. On standard grapes or lower tannin concentration grapes, we will use SOFTAN V, 150 to 200 grams per ton. If you do have a very strong tannic structure already and a high phenolic potential, you don't have to use more tannins. Maybe we can work just with Nature Soft. 20 to 30 grams per hecto will help you stabilizing these tannins and also stabilizing the mouthfeel. Then we are going to arrive to pressing. You press whenever you want and you reach your extraction level. And then during aging, which I didn't talk now, and also the pre-bottling part. But during aging, you can mainly, we want to focus on protecting these compounds from oxidation. So you want to limit your DO, you want to increase your aging potential and manage your redox potential. And this will be done with lees aging, oak tannins that you can add through barrels, through oak chips, oak staves, or even powder tannins. And grape tannins can help, especially if we are talking about varieties that are pretty low naturally in tannins. Okay, so Vinitan Advanced is our grape skin tannins. Tannin Sense is our range of oak tannins. Pre-bottling, we will talk about monoprotein such as STAB-K that are able to stabilize color and make sure you don't have any precipitation in the bottom. Okay, so this was the different product and also tips and tools you can use to stabilize color and manage phenolics in a red wine fermentation. I would like to thank you very much for your attention. If you have any questions, that's going to be the moment. We are going to open the Q&A. If you have questions later, please feel free to email me at eglantine.chauffour@buchervaslin.com or visit our website. Thank you very much.